Today's lesson is on vectors, and these words going down the side of the page are all vocabulary that you need to know. So we filled it in ahead of time. This is Ms. Deloach's handwriting. Okay, but basically a vector is a directed line segment. We use this notation. You could have U, have A, but they put a little arrow on top. All right. The length of the directed segment is the magnitude. Usually we're talking about forces. A 20-pound force at 30 degrees. Direction is the angle the vector makes, okay, or they call it amplitude. So when you draw your vectors, you have an initial point and you have an ending point. Let's do here. The initial point and an ending point. You have to put the arrow on it, okay? Well, this is in the x direction, so we call it the x component. This is the y direction, so it's the y component. All right. When you add vectors together, you add the initial point of the second one starts at the terminal point of the first one. So if here's my first vector, here's my second one. So initial, terminal, and then this is the resultant. Okay? So that's how you add vectors together. That's the picture right here. All right? So the resultant is what happens when you add the vectors together. Standard position means you're putting it on the grid, and you have a initial side, and here's your terminal side, and it rotated up. All right, that's standard position. It started at the origin. When you multiply a vector by a constant, that's scalar multiplication. So I can say 3 times vector v, and that makes it 3 times longer. Okay, a negative vector is different than the unit circle. Let's get rid of this one and this one. Okay, here's my initial vector. The negative, let's get rid of the 3. The negative vector goes this way, in the other opposite direction, 180 degrees. All right? So today's lesson is really drawing vectors, and sometimes you're giving the magnitude and direction, and sometimes you're given the what are my words I'm looking for? The components. That's the word I'm looking for. All right, so they want you to sketch V with a magnitude of 2 centimeters and a direction of 24 degrees. So you need to start with a line. You need your initial point. I'm going to measure 24 degrees. And I'm going to get my ruler out and measure 2 centimeters. All right. This is the x component. This is the y component. All right. Sketch U with a magnitude of 3 and a direction of 100. So you start yourself a straight line. 100 degrees is a little past 90. You measure 3 centimeters. And that's 100 degrees. Okay, and this time its components are here. Alrighty? Now, I want you to draw the vector given the components, 3, -2. These little pointy things, I call them pointy jobbies, let you know it's a vector and not an ordered pair. Those are the components of my vector. So if I put this on a grid, I'm going to go over 3 and down 2, and my vector's down here. This is the angle of my vector, and this is the magnitude. All right. This one, the components in the x direction is -5 and up 8. Here's my vector. So here's my angle, and this is the distance, okay? So this is -5, this is 8. So how am I going to find the magnitude of this? Well, that's what the next part says. It's a triangle. A squared plus b squared equals c squared. So the magnitude we use, it looks like absolute value. I put this in there so I know that I'm doing the magnitude of a vector. It's a squared plus b squared and take the square root. The direction, you're going to do the arctan, okay? Because the tangent, like in that one, is equal to 8 over 5, negative 5. But when you do that, it gives you your reference angle. So you're going to have to add 180 or subtract it from 180 so you get in the right quadrant. And that you just need to know. Use your positive and negative components to tell you that. Okay, so you're given the magnitude and direction. You want to find component form. All right, so here's the magnitude and the direction. Component form. You find the magnitude times the cosine and the magnitude times the sine. For example, let's sketch this thing. 166 degrees gets you over here. And that's 3 centimeters. My components are going to be 3 times the cosine of 166 and 3 times the sine of 166. And these you get to use a calculator for. Make sure it's in degrees because you're in degrees. Let's see. Setup, angle, degrees. So I have 3 times the cosine of 166. Tells me it's negative 2.911. And 3 times the sine of 166 is 0.726. And to get the magnitude, I'm going to do the inverse tan. Oh, I already have the magnitude. Sorry. Did that. Never mind. Never mind. They told me it was 3. Okay. This time they gave me a magnitude. And look at this. You have the x value is negative. Sure it is. And the y value is positive. And it is. You're in the right quadrant. Okay. Vector at 2.5 and the angle of 120. No calculator. So you're going to be exact. That came off your unit circle. 120 is right here. That's 2.5. So my components are 2.5 times the cosine of 120 and 2.5 times the sine of 120. Well, I don't know the sine and cosine of 120 exact, but I do know that that's 2 pi over 3. Okay. And the cosine of 2 pi over 3 is negative 1/2. And this is 5/2. I like to work in fractions. And this is 5/2 times the sine, which is root 3 over 2. So you get negative 5 over 4 and 5 root 3 over 4. And it's exact. I don't want a decimal from that. It means you use your calculator and you don't get one. Okay? All right. We're switching gears. They gave me the components and they want the vector, direction, and magnitude. So here I am. I went 1, 2, 3, 4 down. It's down here. 3 and 4. So I already know the magnitude's 5. Okay, because it's 3, 4, 5 triangle. I do an inverse tan of negative 4 over 3. When I put that in my calculator, I do shift, tangent, negative 4 over 3, and it gives me an angle of negative 53.130. And that's okay, because it is negative. So that's my degrees. So there's my direction, or amplitude. There's my magnitude. This one, watch out. Okay, so here I am. I'm at negative 5, negative 12. So I know this is 13. So my magnitude is 13. You should know those special triangles. I'm not going to do that over. The direction, I do inverse tan, and negative 12 over negative 5. Well, the calculator knows that that's the same as positive 12 over 5. You can put in the negatives. And it tells me 67 degrees, 67.38. If you give me that answer, it's wrong, because it's obviously not. Okay, it went all the way to here, so I have to add 180 to it. So I add 180, and I get 247.38 degrees, and that's the angle. So be careful of that. Draw your picture so you know which quadrant you're in. So when you get an answer of 67 degrees, you're going to know it's not right. And that's all I got for you. No Zoom today.